Hello everyone. When we left off, we used the symbol table to catch some basic errors. So this time around, we are going to add some while loops to our little compiler. So the first thing I'm going to do is that I'm going to define a while loop. So I'm just gonna quickly just create a while loop. While and then token less than. In my Lex file, I'm just going to add a while loop. While and then less than sign. So less than sign. Return LT. Just to just quick. Add a struct node, yeah. Yeah, I should just. Yeah, I needed to add the struct node, so yeah. Yeah, there we go. So yeah. Everything passes correctly. I just needed to add struct node. Yeah. So I guess what are we gonna do for our while loop? I guess the first thing that we can do is that we can take a little what do we call it? A little page from our function calls, from our function statement. In our function statements, as you could see here, we had statements equals $5, and then we added the statements code to the function. And I guess in a similar fashion, we can do the same thing for a while loop. We can add the while loop body in between. We can add the while loop body in between the code for the while loop. So we just do 1, 2, 3, 4, 5. So statements is 5. Then what we can do is that we can generate the code for a while loop. So for the while loop, what you want to do is that you want to generate the code for the beginning of the loop. You also want to generate some code for the end of the loop and a condition to break you out of the loop. So if we go back to the middle interpreter instruction set, we can look at the instructions inside the middle interpreter, and as you could see here, the colon equals label is how you go to a label. The question mark is how you. The question mark equals colon is label predicate, and the colon label is declares a label. The first thing we're gonna do is we're going to set it equal to. We're gonna set the code equal to the beginning of the label. So begin loop. And at the end of the function, we're gonna have end loop like that. And we're going to have a little thing. We're going to have a label to take us back to the top of the loop. We're going to have a jump statement that takes us back to the top of the loop. So colon equals label. Colon equals begin loop. So what is happening is that we have our begin loop label at the top. We have our go-to label. So this one takes us back to the top. And then we have our end loop. So, and in the middle, we're just going to include the statements body. We're just going to include the statements generated code. and we're going to pass all of that code back up the stack, back up the grammar parse tree. So if we run this, then it doesn't like $5. Okay, so statements 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. Oh yeah, 6. Okay. Yep. So I guess we generate we generate some basic code for a loop. So if I do mill run on output.mil, we get an infinite loop. As you can see from the parser.y, we have begin loop, and then we have end loop, which takes us back to the beginning. So now we need to generate the code for variable less than variable. So that is going to be something like a less than 110. So I guess what we're going to do is I'm going to say node code plus equals let me think. Let me think. So we're gonna get the first variable. So the first variable is going to be $1. var1 is going to be equal to $2. The next one, var2, is going to be equal to $4. We're gonna say std string less than sign. We're gonna create a little temporary variable, so a temp variable to store our information, followed by doing a temp variable, followed by var1 plus var2 plus then if the node code, so std string. So I guess the syntax for the loops, it's question mark colon equals. So we're gonna do question mark colon equals. I don't know. Loop body temp. The loop body is going to be a label that we define. The predicate is, if predicate is true, 1, then go to label. So we have the predicate, which is going to be temp. Temp, it is going to be less than. It's going to be the less than sign. So yeah. This is what we're gonna do. We're gonna do node. We're gonna add another string, which is loop body, and then in between that stuff, we're gonna say string. So colon equals and loop. Okay, so what this code says is that go to the loop body if the temp is set to true, so we skip over this instruction if we find that there is no, if the temp is true, then we skip over the end loop instruction. So if this is true, then we skip here. If it's false, then we just go to the next instruction, which is this one, end loop. Then if we hit the go to end loop, then we just jump outside of the loop and we end the while loop. So with all that being said, if I did this correctly, this should correctly end the loop. Output.mil. Waiting. Okay, mill run, output.mil, and yep, as you can see, we have ourselves a loop file. It goes from 1 to 10, so it starts as, we start at I equals 0, we keep incrementing, and then we print out each number. So, and as we run the mill code through the mill interpreter, we get 0 through 9, we print out 0 through 9. That's all that I have for this video. I think that the rest of the assignment 4 should be pretty straightforward. Just sort of following this pattern, except for if statements, and then there's also some nested loops, there's also break statements. They should all be following a similar pattern.